Hello everyone and welcome to another video of the Hidden Quantum Champions. Today we are looking into another company from the field of the quantum technology, which is called Pasqal. And with that, let's dive right into it. So here we are at the website of Pasqal. It says FTQC blog part 2. So there's like different items down here. We will look at this later, but for now, let's quickly scroll down here. So we see like different publications, PhD, atoms, 1000 plus. So that may be already indicating into which direction this is going. Then it says our success stories. So there are like customers already here, like Thales, BMW Group, Capgemini. There's something more here. Your journey to quantum reality. So there's like something about the hardware, the software, get results in 4 weeks, and the cloud, and the contact us. And then there's something about trusted partners here. So we see IBM, NVIDIA, Microsoft, the Institut d'Optique from Paris Tech. So that's, I think, also where this originally spun off. There's quantum computing for every industry. So here we see the different industries that are basically target audience for the solution here. And the quantum roadmap, which says 2022, 200 qubits. So from that, we can already infer that like here we are looking into a company that is producing quantum computing hardware. So in 2022, they started with 200 qubits. 2023, it's 200 qubits, the Z addressability and 1 Hertz. And the products are Orion Alpha and the cloud availability. In 2024, we have 1000 qubits and a 1Q and 2Q, so 1 qubit and 2 qubit gates. We see there Orion Beta, 100 plus qubits, and the on-premise delivery is available. So they started first in the cloud, and then they also moved on-premise. And now 2025, it's 1000 qubits, 2 logical qubits. So logical qubits as in, I guess, error-corrected qubits. They added the technology of atom shuttling. So from that, we also know that they're working on atoms, probably like neutral atoms, otherwise it would be ions. And it says ultra-high fidelity gates. And then there's Orion Gamma as the next product and 140 plus qubits down here. Okay, with that, let's jump into the technology part of things. So understanding quantum computing. Beyond classical, understanding quantum computing. There's an infographic here. For decades, classical computers have been the foundation of technology advancements relying on bits, so 1 or 0, to process data. The binary logic has powered everything from simple calculators to the most advanced supercomputers, which is, I mean, what is being used today. Even in like the fancy NVIDIA GPUs, it also uses ones and zeros, binary computation. However, we push the boundaries of computation. Certain problems remain unsolvable within a reasonable time frame. This is where quantum computing comes in. By harnessing the principles of quantum mechanics, quantum computers process information in ways classical computers can't, unlocking new possibilities. They excel at optimizing complex systems, simulating molecular interactions, accelerating machine learning, and designing innovative materials, transforming industries from logistics to drug discovery, finance, and material science. And there's also a video down here. Fundamentals of quantum computing. So there's the quantum bit or qubit, which does not only operate at 1 or 0, but on this whole sphere of different states here, which is called the Bloch sphere. There's the concept of superposition, where the system, when measured, is not at one of those states, but like at a probability spread between those two states. And then there's the idea of entanglement, where you kind of combine 2 different qubits with each other, so that like if one, for example, is in the state 1, the other one is automatically in the state 0, things like this. And there's an infographic here. Why it matters. The unique quantum properties are what researchers hope to harness to revolutionize fields like cryptography, drug discovery, and complex system modeling, consider many possible solutions simultaneously, create powerful correlations between qubits, and solve certain problems exponentially faster than classical computers can. Here's something about the technology, and then here it says neutral atom, the future of scalable quantum computing. And then, okay, there's a community space here where you can register. There are publications down here. I'm recording this beginning of September. We see that like here it's June, March, April. So maybe not so many publications here for now, but I think there might be something, there's enough interesting material going to be out here. And then there's also real world use cases here. So you see, I think it's going to be research, but you also see here something which looks like a space related thing. Advanced Institute for Science and Technology, Capgemini Consulting, and BMW in the car manufacturing space. Let's quickly hop into the technology that they are using, which I think is anyways going to be the next one here. So scroll to explore. So this is going to be an interactive experience now. So we're scrolling. Quantum computing has transcended the realm of theory. It's now available. It is now available technology with a track record of powering transformation. Advanced in neutral atom technology are now translating into tomorrow's everyday applications. Business everywhere must harness the infinite potential to step into the next phase of their development. Our ambition is to break through the limits of computing by leading the delivery of state-of-the-art quantum computing. At Pasqal, we have built much of the foundation that allows us to guide you through this new era. Have a look at some of the case use that make use of the case uses that make use of the power of quantum computing. Let quantum computing find concrete solutions to your real world challenges. Okay, from hard science to actual hardware. Okay, then we see your journey through the quantum reality. So now we go in here, our solutions and offerings. Okay, so now we see here a lot of optics, different lenses. I think there's like some coils down here. Cold atoms are so hot right now. So, okay. Real science, real world, real business. And then we are hopping in here. Now we see the atoms and some lasers and some coils that and then there's another optics operation happening here. And now, okay, now we see the different industries again. Okay, that's a very nice zoom in. Let's see something. Okay, we've seen that already. Let's quickly hop onto the roadmap. I think we've also seen the current state already, but here's now the roadmap of where things will actually go. So here we are in 2025. That's what's happening right now. We see up here, I guess, the different hardwares that they are looking into, the physical qubits that are in the system. We see the pre-step fidelity, so that's also increasing. We see the base preparation rate. So it started at 1 Hertz, and now we are like in the 3 Hertz range. This will go up and triple to 10 Hertz, and then there will be 100 Hertz plus starting from like roughly 2028. There's new features happening. So Z was being added, zoning, in-circuit readout, in-circuit reloading, fast decoder, large-scale operations, and it's going to move from 20 qubits to 10,000 qubits in 2029. There's also full addressability coming here in the roadmap. They have logical qubits, so this is starting right now with 2 logical qubits. We see the physical qubits will expand to 50, but it will stay at 2 logical qubits, increasing the fidelity and also the logical fidelity first. And then once the step to 200 is happening here, you see that you are like 20 logical qubits, so like, I guess, error-corrected qubits from there. And then, okay, there's also some information here about the algorithms down here. So there's like Slurm integration, quantum advantage on quantum matter, GML apps, and optimization applications that are already like in the work here. And then once it moves here, we have more stuff adding up, like hybrid programming model development, all the way down to low latency hardware co-location. There's quantum advantage and optimization and machine learning coming, and specialized libraries for quantum simulations, quantum optimization, and graph machine learning. And then there's also some digital FTQC SDK and applications coming here towards 2029. So that's like a long roadmap already ahead. You can also download it here. There's also a webinar explaining that. I think I might go after the video and then check that one out. And then there's some news here on the latest achievements, like Pasqal exceeds 1000 atoms in a quantum processor. Let's also quickly check out these ones here. So there's analog and digital. I think that's something that we've seen already before, which is possible with these neutral atoms. You can basically switch between analog and digital quantum computing. That's also explained here. So analog quantum computing traces its roots to the early days of quantum mechanics, focusing on continuous systems that evolve naturally according to the laws of physics. This model quantum systems are allowed to evolve freely under the influence of carefully controlled Hamiltonians. So Hamiltonian is basically like the energy landscape, more or less, that you put these atoms in, making them exponentially powerful for simulating natural quantum phenomena directly. So you can, maybe even emulate. So you kind of put the atoms into a energy level system, and then you let it evolve. Kind of what, in a way, probably similar to what annealing does, but really in a continuous space here, because it's like, as it also says, like freely under the influence of carefully controlled Hamiltonians. And then you make it evolve. But there's also this digital part here. So digital quantum computing, which says digital quantum computing builds on a different foundation, one closer to classical computing. It uses discrete operations known as quantum gates, and we've talked about this before, to manipulate qubits systematically. This gate-based approach excels in tasks requiring precision, error correction, and programmability, such as cryptographic algorithms, complex optimization problems, and digital simulations. So that solves a wide range of problems, whereas that one here is more like tailored to specific, probably optimization problems, or like emulating quantum systems. This one is less prone to error, whereas this one needs the error correction right, so it uses more resources and requires more error correction. The synergy between analog and digital, the true power of quantum computing emerges when we harness the best of both worlds, analog quantum systems with the ability to naturally simulate complex quantum interactions, provide an unmatched level of efficiency for certain problems. Meanwhile, digital quantum systems offer the flexibility to execute a broad range of programmable tasks with high accuracy. This hybrid approach doesn't just enhance performance, it broadens the horizon of what quantum computing can achieve. It means using analog simulations to solve problems directly when possible, then switching to digital for tasks that require more structural algorithmic solutions. And then, Pasqal expertise in neutral atom technology. Pasqal's hybrid approach is gaining recognition as one of the most promising paths to achieving quantum advantage, the point where quantum computers can outperform their classical counterparts for practical tasks. And then there's a community here where you can register and join for collaborative work. Okay, there's something about error correction as well. I will not hop into the details here for today, but if you're interested in the topic of error correction, please let me know. We can do a separate video about that. Here, I guess it hops a little bit into that. We can, for example, start by checking out this one. Then there's also about the Pasqal and IBM collaboration. So apparently they are working together on something. Here it says IBM and Pasqal are partnering to develop a unified approach to quantum-centric supercomputing, combining the expertise in superconducting and neutral atom quantum technologies. Together, they aim to accelerate real-world applications in chemistry, material science, through open source software and hybrid quantum classical workflows. This collaboration marks a major step towards scalable utility-driven quantum computing across industries. To expansion, IBM and Pasqal are joining forces to develop a unified hardware-agnostic programming model for quantum-centric supercomputing using Qiskit. This collaboration will allow users to seamlessly combine IBM's and Pasqal's quantum hardware with classical high-performance computing sources in a single workflow. As a first step, Qiskit users will soon gain open-source access to Pasqal's neutral atom quantum processors. So that's also a very interesting thing here, because this is something which I've also pointed out many times already in the past. So we have all of these different quantum systems, and none of them is perfect right now. So there's not one system which is like perfectly error corrected with a large number of qubits, which you can use for all the types of tasks that you want to. And we don't know if or when there will be, right? But for certain types of tasks, certain types of systems seem to be better than others. So let's say you, for example, need a system where you have a high connectability between different qubits. It might be that an ion-based system is performing very well because you can you can connect every qubit in this one-dimensional line with every other one perfectly well. Now, there might be one where you need to be very fast because you need to have a feedback very fast about like you're feeding in data and you need to get the output very fast. In this case, for example, it might make more sense to actually use a superconducting qubit because usually these systems, they operate on a radio frequency type of signal processing, so they're very fast and actually performing all those operations. They might also be very interesting if you want to do a lot of gates in sequence, which in another system might take too long. So they're like different types of systems for different types of tasks. And what I would like to see actually is like a compiler that kind of looks into what algorithm you're writing and then helps you to decide, okay, which system does it go on? And with that, there comes a lot of additional complexity, right? Because now you need to have, let's say, one programming language that can be deployed in various different hardware systems. So that means like you need to have some way to compile that programming language into the actual operations on the system. You also need to have a compiler that is aware of all these boundary conditions and that knows which system can do what. And if I understand this correctly, and if I see this correctly here, this is actually where this is moving towards, because you see that IBM is working on superconducting qubits, you have Pasqal, which is working on the neutral atoms, and in addition, you have the classical high-performance supercomputer. And on top of that sits Qiskit as an open source language that was, I think, mainly developed by IBM to kind of, once compiling, facilitate, I guess, between those different sources and kind of making sure that your inference, that like running the code, is being done optimally given the systems, the subsystems that you have at hand. So this is actually something very interesting to also watch out for as it develops. Now quickly to the solutions. So we see there's a lot of things happening here. We have different products, hardware, cloud, and software. We have different industries, so this is like where the solutions are catering to. We see it's aerospace and defense, banking and finance, energy and utilities, government and public sector, manufacturing and material science, pharma and healthcare, transportation and mobility. And then there are also ways to work with them. They have professional services. I guess that's like kind of a consulting where you get help to actually identify problems that can be solved on quantum systems, or that potentially can be solved on quantum systems in the future in your company. There's like a partners tab here, and then there are also success stories. Finally, we see there's also resources here. There's a newsroom, a blog, there's events, publications, so analyst reports, scientific publications, success stories, and white papers. There's a learn more part, which is always very important to me, because we are here at the School of Quantum. We want to learn about the quantum technology, right? So here they have a community-based approach, and there's also an FAQ here. Finally, there's also the About Us page, which tells about the history of Pasqal, about Pasqal itself, shows you the management team, board members, and brand guidelines. There's also some partners, investors, and join Pasqal. Very quickly, let's go through the solutions part here. Let's quickly check out the hardware, then maybe hop to one industry, and then look at the professional services as well. So hardware, we see here, it's like room temperature operation, 200 qubits, 3 kilowatts of compute power, and it operates at 15 to 20 Celsius. Here's what the units look like. So there's JAMA and there's VELA as, I guess, the next level. You see the 140 qubits here and the 200 here. It will have a lower noise level, and both of them have an analog mode, and they work on an open source framework, and you can get a quote already. So it's like, so Gamma is available in the market, and VELA is going to be in 2027, but open for pre-order already. There's the HPC integration. We saw that before with high performance compute centers. There are trusted partners here. So we see the CEA in France. There's also the Forschungszentrum Jülich, which I always like to point out whenever I see it somewhere, because that's where I also used to work as a PhD researcher. So happy to see them here as well. There are some notes here why to choose Pasqal, energy efficiency, hybrid quantum classical integration, high scalability, full stack, which also refers to the software ecosystem they're working in, and modular design. So individual hardware modules can be upgraded to stay on par with the state of the art without needing to replace the entire QPU. So then, okay, here you see our QPUs are ready to solve your toughest problems. Let's innovate together. So there's this consultant step where you have experts that actually find the business applications. There's some experiments here on our neutral atom QPU via the cloud. And then, okay, if you want to move on towards security, a QPU and have it delivered. So secure your own QPU, have it delivered, and then use it on-premise, and then start with the quantum computing journey. Then there's also learn more here. On the solution side of things, let's just take maybe aerospace and defense as it is the first one. There's a success story here with Thales, which is also a very big company, big technology company here in Europe. It's about aerospace engineering, advanced mission planning, and geospatial analysis. There are some explanations here. So simulate aerodynamics, enhance material science, and propulsion systems, advancing aerospace innovation. On the advanced mission planning, it says optimize mission parameters, route planning, and resource allocation for complex military operations. And for the geospatial analysis, it says accelerate geospatial data processing, optimize analysis, surveillance, and strategic decision making. Okay. And then we want to quickly hop into the professional services as well. So here we are on the professional services. It says from training to real-world applications, we help to turn quantum potential into business impact. From learning to leading, we help to turn quantum potential into business impact. So it basically starts with a training approach here, as it explains. So you will learn like the basics, I guess, about how the whole idea work, and then it says bridging theory and practice to accelerate your journey into a real-world application. And then there's application projects. Bring your project or use case and let Pasqal handle the quantum computing. Our experts take care of the programming and deliver a proof of concept on a real quantum computer. And then, yeah, we have here again cases. Now we also see Crédit Agricole as a bank, EDF, and again KAIST, and the partners. Okay, then I think we are done with the solutions part. Now let's quickly check out the company. So very briefly about the history. Founded in 2019 as a spin-off of the Institut d'Optique, Pasqal emerged from groundbreaking research in neutral atom quantum computing led by quantum physics pioneer Alain Aspect, who also won the Nobel Prize together with his colleagues not too long ago. I don't know if it says something about that here. Not sure. But that's maybe a very important side note. Quickly about the company. So Pasqal powers transformation. Many people call quantum computing the next big thing. We believe it's already huge. So 2019, inception of Pasqal. Then, okay, here we see it. Nobel Prize in Physics awarded to Pasqal co-founder Alain Aspect in 2022 and headquarter in France. Pasqal, the leading quantum computing company. At Pasqal, we've spent 4 decades leading and mapping the revolution so you can power up the next phase of development. We have the state-of-the-art technology, the methodology, and the people so business can tackle the big changes that will define this new era starting now. Our mission, from single atoms to global impact, our passion for science helps interpret the complexity of the world, our vision to break through the limits of computing by leading the delivery of state-of-the-art quantum computation. When there are no fundamental limitations, engineers find a path. From the professor and Nobel Prize winner Alain Aspect. So then we see here like the different solutions or the full stack approach, hardware, software, and cloud provided here. Brilliant minds, real impact. 300 employees, 75 PhDs, 30 nationalities. I think here we see some highlights in the map. Oh, I would have guessed that this is like something saying about the office, but yeah, they have locations around the globe. Multidisciplinary minds, infinite solutions. And here it says something about the Professional Equality Index of the year 2025. Okay. With that, I think we are done with Pasqal for today. I hope you liked it. And if you liked it, please let me know by giving the video a thumbs up. And looking forward to see you in the next one. As always, make sure to stay hydrated and see you then. Bye bye.